Yeah, you could just read this on your own, actually. I think you guys are good enough for this. Okay, I'm just gonna quickly discuss this, I suppose. Okay, practically, how do you do that? Here, you load data set. This is wholesale customers data set. Yeah. As usual, you do some EDA. It's important to do EDA because there are some things that you have to pre-process first if you inspect the data. For example, the channel in the region. So they are not ordinal data. So you should convert them. You should apply one-hot encoding, for example. Those are the things that you will know if you do the necessary EDA. So I did that, the encoding, blah, blah, just to get them using one-hot encoding. Then feature scaling, right? I always emphasize this part. You have to perform scaling. Easier for your models.
Sir, hello.
Yeah.
I just noticed that the scaler you use there is min-max rather than standard.
Yeah, I just want to show you that you could use different scalar and it can affect the clustering because you have different data now. But up to you, you could use different scalar. The thing with clustering and unsupervised learning is it is supposed to be validated by the domain experts. There's no right answer. There's no one right answer in unsupervised learning. So what I'm trying to show here is that you can just play around with different scaling, different pre-processing technique until you end up with a result that is acceptable by the domain expert. So where do you typically use clustering use cases? I don't know, like customer segmentation. Maybe your client is like something that's relatable. Maybe for elections, you want to identify your different customers or the different people, groups of people that you want to target. You want to target these people using this campaign and A for using this campaign, to B using this campaign. So you could use clustering for that. Now, it will be validated by the domain expert. You do your modeling, you'll have an output. You say that this is my cluster A or group A or and cluster B, group B. Does this make sense to you? They will say, okay, yeah, those clusters, those groups of people do make sense. Now let's make a campaign. So that's how it works. There's no one right answer. It has to be validated by the business people or the users or the clients. And going back to the modeling. So you could use whatever technique that you'd like until it makes sense to the customer. We scale it. Then we do clustering. Use k-means. It's an scalar as well. So what is this thing? You could choose the optimal number of clusters because that's one of the parameters in k-means. You have to specify the clusters. And one way to identify the optimal number of clusters is the elbow method. You just copy this code, basically, then visualize it. So where does the elbow occur? It's at k is equal to 4. You visually inspect that. But there's a proper way of doing it. I'll show that in a bit. Actually, later there's that. Should be, wait, it should be here. Why is it? It's weird. That is weird. I'm looking for that code. Hold on. Why is it gone? It was always there. Hold on. I think I'm, wait. Here. Yeah, more details. So you have more metrics actually that you could use. You could display all of them. Here's the explanation or guide on how to read the graphs. it is really not straightforward when it comes to clustering. You basically look at different metrics and say, yeah, the best number of clusters seem to be this one for this particular data set and metrics, but for the other metric, this is this one. So again, validated by the end users at the end of the day. So you choose different configurations, ask them if they make sense. But I just want to show you that you could display different metrics, and then maybe you want to use the Kaninsky-Harabast index for this one, check the best number of clusters, or maybe use the SSE or elbow method. Up to you. Here's the guide, just read it. There are different metrics that you could use. Just run the code, and I've provided the template already. Yeah, and yeah, for the different metrics. But for starters, just use SSE. Just use SSE for now, and you could use the needle algorithm. So just use that, and it will automatically identify the elbow point. So it's 4. If you use that, it will automatically show that. So yeah, use k-means, elbow visualizer, fit the data set. Sorry, fit the model using the data set, and then show. That's it. Just this.
Sorry,
This code to do everything.
can you go up one? No, sorry. Can you go up one chart graph? There, sir. So I'm assuming sorry. Am I assuming that squared errors less is better?
Wait. Yes, less is better.
So if less errors are better, why is our K4 rather than say
good question.
Anywhere higher, where the errors are lower?
I hope this makes sense. I think after some time you'll be enlightened to understand this. But for now, the real answer is, what is the best? Okay, I'll ask you a question, and then let's see if you can figure it out. What's the best number of clusters, given whatever problem you have, given like say 100 data points? What do you think is the best clustering? Number of clusters, basically. What's the best number of clusters given like 100 data points? What is the number that will give you the least errors? Or let's make this simple. We have a group of 5, you, me, and 3 more people. What is the best way to group ourselves? In such a way that there will be less errors, or ideally no errors. So basically, if I say that you're in a group, you're really alike. What do you think, given a group of 5? What is the best number of clusters? Any guess?
My guess goes in both extremes, either just 1 so that all of them are clustered, or 5 so all of them have their own cluster. I have no clue really.
Okay. The output here already gives you a hint. It's the maximum. Think of it this way. All humans are unique. If I group you with some other person, of course, there's going to be differences. So you don't expect that you will get an error of 0. And that is why if you have a number of clusters that is equal to the number of data points that you have, then that means you have a single group for each data point. And what is that? 0 error. Because the centroid of each cluster is exactly each data point. There's no error. Got that?
Yes, sir.
So that is why in that sense, the best is the maximum. But that doesn't help us, right? We want to group things. Again, we want a lower number. So that is what the elbow method is showing. It's like I'm just using few clusters, but that already explains a lot. There's a minimal error. I mean, it's not zero, but it's still low. But I'm using just 4 clusters instead of like hundreds. So that's the intuition for this. Use the
So
least number of clusters to explain the most.
okay, so it's in a way it's compromising between accuracy and actually
Yeah.
doing its job.
Yeah.
Ah, okay.
Yeah. Yeah.
All right. Thank you, sir.